All right, guys, Mr. Antonucci here, and in this video, I want to show you how to quickly and easily construct a slope field for a differential equation. So you'll come across this from time to time in your calculus class, and it's pretty simple to construct a slope field, but you have to keep your work organized and neat and just keep a couple things in mind as you go here. So for this one, we have the differential equation dy dx equals 2x over y. And so what we're going to do is we're going to create our own table of values based on the points that are given on our graph. And typically when you're asked to construct a slope field by hand, you're usually going to have to do it between 8 and 12 points on a graph, maybe a couple more, usually not less than 8, but certainly not 30, 40, 100 points. Even though that would give you a more accurate looking slope field, it's just too much to calculate by hand. So what a slope field is doing is it's giving you a picture of what the general solution curves to the differential equation might look like. And so as you can imagine, the more points you would have, the more accurate it's going to be. We have 12 points here, so we're going to get a little bit accurate, but not super accurate. But the focus here is on how to construct them correctly. So one thing you want to do is make a table of values based on the points, x and y, and then dy dx. And I picked this differential equation 2x over y intentionally because some neat things happen with this one. So what I'm going to do is I'm just going to list the coordinates of the points starting with the leftmost column of points. So this point is -1, 2, then -1, 1, -1, 0, -1, -1. So we get all 4 of these points. Then we'll move to this column of points, be 0, 2, 0, 1, 0, 0, 0, -1. And then the last column of points would be 1, 2, 1, 1, 1, 0, and 1, -1. And then what you want to do is figure out what the slope from the differential equation is at each of these points. So at -1, 2, you're substituting -1 in for x and 2 in for y. So that would give you -2 over 2, which is -1. And what you want to do is you want to put a short little tick mark at that point with a slope of -1. Now, a slope of -1, you go down 1 over 1. So it would be at this kind of angle right here. You don't want to extend it too far, but just like that. Then at the next point, x is -1. So you'd have -2 over the y value, which is 1. So your slope there would be -2. So the slope at this point is going to be negative, but it should be steeper than this point since the slope is -2. And so you can go down 2 over 1 and kind of imagine what the slope would look like there. And often when you're being corrected on your slope field for a differential equation, they're going to look to make sure that the tick mark is going in the right direction. Is it a positive tick mark, negative tick mark, or is it horizontal or vertical? We'll get into that. And is the relative steepness there? For example, if this is a slope of -1, then relatively speaking, this one should be steeper. Doesn't have to be perfect, but should be relatively correct. The next one is -1, 0. So -2 over 0, which is undefined. But in this case, since you're dividing by 0, you're going to have a vertical tangent line. If you remember from algebra, when you have a number divided by 0 for your slope, you're going to have a vertical, it's just a slope of a vertical line is undefined. Okay, and then -1 for x, -1 for y will give you -2 over -1, which is a slope of +2. So we'll put that right there. Okay. Then when x is 0, all of these slopes are going to be 0 except the one where you're dividing by the y value of 0. So this slope's going to be 0, boop, horizontal line. This slope's going to be 0, boop, horizontal line. This slope's going to be undefined, but since it came from 0 over 0, you don't know what the slope is at that point because it's truly undefined. So you would not put a tick mark there. It's not going to be horizontal. It's not going to be vertical. It's just undefined at that point. The derivative is undefined at that point. So then at 0, -1, again, the slope is going to be 0 at that point. Then we move to the next column. So when x is 1, you would have 2 over 2, which is a slope of 1. And then when x is 1, you have 2 over 1, which gives you a slope of 2. So relatively speaking, it should be steeper than the one that we put in previously. Then 2 over 0, which again is undefined, but in this case, since it's a non-zero number over 0, you're going to put a vertical tangent line there. And then when x is 1 and y is -1, you'd have 2 over -1, which is -2. So your slope would be -2. All right. And that's our slope field for those 12 points. So I hope that was helpful to you. If you have a problem or a situation that you'd like me to go over from your math class, put it in the comments below, and maybe I'll make a video about it relatively soon. Make sure that you subscribe to the channel as well as hit that bell for notifications when new videos are uploaded, and feel free to share this out. All right, you take care now.